Hello, you're welcome once again to New Focused Approach to Mathematics Basic 8. This is the revised edition. And in this video, we want to solve problems with basic trigonometric ratios. This lesson can be found in page 215. In our previous lesson, we were looking at the concept of relationship between trigonometric ratios, that is having right angle triangle. What happens with the size of the right angle triangle in relation to the interior angles of the right angle triangle. So this time I want to apply what we've learned in solving questions. Now let's take a question like this. We have a right angle triangle here. They've given us the longest side being the hypotenuse as 10, and then the opposite of this angle is given as 8, and the adjacent is given as 6. They want us to find sine y, cos y, and tan y. Now for sine y, remember we said sine goes as so sine y will be equal to the opposite side of the angle, which is now 8, divided by the hypotenuse side, which is 10. This can be reduced to the lowest form as 2 divide the 8 as 4 and 2 divides this one as 5. So the answer becomes 4/5. Then we want to find cos y. Cos y also comes with the acronym K. So K means adjacent over hypotenuse. So what is the adjacent of this angle? And that is 6. So 6 divided by the hypotenuse, which is 10. Again, we reduce this to the lowest form. 2 can divide the 6 as 3, and 2 can divide this as 5. So we have 3/5. Then the last one, we have to find tan y. And tan also comes with twa, which is opposite over adjacent. So what is the opposite of y? Is 8. Adjacent of y is 6. So we divide that. And that also can be written as 2 divides the 8 as 4 and 2 divides the 6 as 3. And so we can see 4/3 as our answer, or one whole number, 1/3. So that is that. Now let's see another example. Here they want us to find cos x and sine x. Now what is cos x? Cos x, again we say K for cos, K, so K mean adjacent over hypotenuse. Adjacent of this angle is 4. Hypotenuse is not given, so it means we need to find for the hypotenuse, which represent our AC. So using our Pythagoras theorem, we know that our AC squared, which is the hypotenuse squared, is equal to the 2 other sides squared, the sum of the 2 other sides squared. So 3 squared plus 4 squared. Again, our AC squared will be 3 squared is 9, 4 squared is 16. When we sum them up, we have 25. So our AC is equals to 25. To find AC, we square both sides. So we root both sides, and that will give us root 25. And the answer becomes 5. So we can put 5 here now. Okay. For that matter, our cos s, okay, our cos s will be, we say K adjacent of the angle x is 4 over the hypotenuse 5, and that is in the lowest form, so that becomes the answer. Then sine x, sine goes with so, meaning opposite of the angle over the hypotenuse. Opposite of this angle is 3, and so we put 3 there over the hypotenuse, which is 5. So we get 3/5, and that becomes the answer to this question as well. Good. Now let's see the last example. Here we have to find tan theta and sine theta in this diagram. Now, because we want to find sine theta, we want to know the value of x so that we can find its value in terms of finding the sine or the tan. Now we know that by Pythagoras theorem, the longest side squared, that is the hypotenuse side squared, okay, should be equal to the sum of the two other side squares, so plus 16 squared. Now we can expand this part. Take your time and go like x plus 8 times x again plus 8. You end up getting an answer like this: x squared plus 16x plus 64 is equal to x squared here plus 16 squared will give us 256, right? 256. Okay. Now, when we simplify this by grouping like terms, we can have our x squared here. This can move to become minus x here. And then we have plus 16x is equal to 256 minus 64. While this goes to 0, we have our 16x is equals to, so we are going to have 192 here for subtracting 64 from 256. Now we have to divide both sides by 16 to make our x the subject. So we have 192 divided by 16. And when you do that division very well, you end up writing x to be equal to 12. So our x is 12, which presupposes that our diagram can be redrawn as, here we have our r, s is 12, hypotenuse will be 12 plus x, which is 20, and then our side here becomes 16, which our theta also represent like this. So now what is tan theta? Now tan theta can be answered as this. So tan theta will be equal to our opposite, which is the opposite of this angle, which is 12 over adjacent 16. So opposite is 12, adjacent is 16. When you reduce this to the lowest form, we can have 4 dividing 12 as 3 and 4 dividing here as 4, and that becomes our answer. Then we want to find sine theta as well. Sine theta is so, okay, so that means opposite over hypotenuse. Opposite of the angle is still our 12 over hypotenuse, which is supposed to be 20. Reducing this to the lowest form, 4 can divide 12 as 3 and 4 can divide this as 5. And so that becomes our answer. I'm sure with these few examples, you are good to go and you can solve more examples in your book. Thanks so much for watching.